If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 6 and 5. The sum of these multiples is 23. Find a solution that returns the sum of all the multiples of 3 or 5 below the number passed in. Total equals none. Additionally, if the number is negative, return none. Okay, the most obvious solution is just to FIzzBuzz it. The I modulus 3 is none, then add it to the total. That's the most obvious version, but then you might say it's slightly inefficient due to checking both 3 and 5 for all the numbers, or 3 and you're going through all the numbers that way. One approach we could do is check for 3 and then only if we haven't checked the number, check for 5. Not sure this actually makes it any better. We can make it faster if we make it a set and then do check numbers add. They will make this in check faster. One approach I kind of like is to do the whole thing as a one-liner. So we could just use the built-in sum. So that's kind of a nice one-liner, but I've put my head in the way. Using the sum function, and then we have a generate expression for I in range number if I modulus 3 equals none, or if I modulus 5 equals none. So if they pass those conditions, it puts it into this generate expression, and then it sums it. A lot of these code problems have what I call a gag, or a magic spell. You either know it or you don't. This one, I didn't know the gag, so I had to research it. The sum of all members of a finite arithmetic progression is called an arithmetic series. For example, consider the sum 2 plus 5 plus 8 plus 11 plus 14 equals 40. This sum can be found quickly by taking the number of n terms being added, here 5, multiplying the sum of the first and last number in the progression, here 2 plus 14 equals 16, divided by 2. This is the magic spell here, right? The gag. If you know this, you've got it, and if you don't, you can't. There's nothing you can really do. In the case above, this gives the equation so we want the first number, we stick in there 2, the last number 14, and then we divide it by 2, so that becomes 2 and 14 becomes 16 times 5 divided by 2 equals 40. If we just stick in here, so we've got 3 plus 6 plus 9 plus 12 plus 15, the total is 45, but we can also get the number of terms, which is 5, and then do 3 plus 15, and then divide it by 2, and that's 45. And then if we don't want the 0.0, keep it in integers. This is one of 2 magic spells that we need. The other one is how to work out the number of terms without just using Python's len. The number of terms is the limit divided by the step. So if we know the limit is 16, and we divide it, we take away 1, which gives us 15, and then we divide it by 3, which gives us 5. That's how to work out the number of terms. This is the fastest solution. It uses the magic spells. I'll try and work through it. This is the magic spell for finding out the number of terms. This is the set of arithmetic series, which is the first term and the last term. And then we can work out the first term because we're always starting from 1 in this example. The first term is always the step, but just to make it a bit clearer, I renamed it first step using this function. The last step is the step times the number of terms, which we've worked out there. Then the sum, this is the sum of arithmetic series. This is this here. Then we get to the solution. We still have to ditch anything that's below 0. And then we work out the sum of multiples when the step is set to 3. So when the step is set to 3, we go to the sum of multiples. We have the limit, let's say in this example over here is 10, and then we have the step, which is 3. So the number of terms is worked out using this. So the limit, which is 10, minus 1 divided by step, because we've got 3, 6, and 9. That will qualify. And then the first term is just the step. Okay, so we don't even, maybe I'm being over the top. Let's just say the first term is step. Just make it really clear, like what's going on here. And the last term is the step times the number of terms. So once we've got all that, we then plumb that in the thing we got out of Wikipedia, which is the sum of arithmetic terms. So we have the number of terms, the first and the last, divided by 2. That gives us the sum of multiples for 3. Then we work out do the same thing for the sum of multiples of 5. And then we do the same thing for the sum of multiples of 15. And then we return 3, the sum of multiples of 3, the sum of multiples of 5, and then we deduct the sum of multiples of 15. And that should happen instantly. It's 01. It doesn't have any loops. It just works it out using maths. There's no loops. I wonder if it runs all the things. It does. There we go. So that's the Garrett on this one. That's the magic spell. All these are about CPU efficiency. Generally, that's not how life is going to work out. Your constraints are going to be the network, the database, making these a tiny bit more efficient. There are going to be some cases with hardware and really fast transactions where it matters, but 99.99% of the time, one of the simple solutions would have done perfectly fine. Anyway, that's really fun. I like that one. I hope you found it interesting. You got to this point, so love you. Bye-bye.